everyone, welcome back to my channel. I'm come back with a new interesting topic, that is design and implementation of master slave JK and SR flip-flop in the subject of digital system and design using Verilog. Let's see the contents on this topic. In contents, firstly introduction and what is flip-flop, master slave JK flip-flop and SR flip-flop, implementation and stimulation and testing, and applications. Finally, conclusion. Introduction. Flip-flops are fundamental building blocks in digital electronics capable of storing binary information among the various types of flip-flops. Master flip and JK and SR flip-flops are widely used due to their enhanced functionality and stability. What is flip-flop? Flip-flops are essential components in digital electronics used in store binary. They are sequential logic circuits that can maintain one or two stable states until triggered to change by an signal. Master slave JK flip flop. Master slave flip flop are the cascaded combination of two flip flops among first is which the designated as master flip flop, while the next is called slave flip flop. Master slave flip flop consists texto cascaded section, each capable of string a binary symbol. We can see on the screen a symbolic representation of JK master slave JK flip flop. There are two inputs, that is set and reset. Set is 1 0 and reset is 0 1, and we have two outputs, Q and Q plus, or Q naught or Q bar, and clock is connected to master slave flip flop to slave flip flop. In that, diode is connected. In internal structure of a master slave JK flip flop in terms of NAND gate, and an in figure below the inverter is shown figure below. Inverter is shown the first four NAND gates from the master part of the, while similar arrangement of other four gates form a master slave flip flop. The part we can see in the symbolic representation of master slave JK flip flop. There are four NAND gates are connected into master slave, and four diodes are connected to slave flip flop. And the time is verified the time diagram. As shown, the slave is divided by the outputs of the master 1 and 2. The master is activate during the positive edge of the clock, due to which M1 and M2 changes their states depend on the values of JK flip flop. However, this staged the overall outputs by remaining uncharged as a positive edge of the clock. Slave is the inactive for positive edge of the clock. Similarly, decides its op-amp depend upon its inputs M1 and M2, or M1 A or B. during the negative edge of the clock. This time however the master slave is inactive. Let's see the truth table on this master slave JK flip flop. The triggered clock and inputs are to JK and J and K. Their present state Q and Q bar. Intermediate state M1 and M2. Next state that is Q bar. Interference stage. When the clock is above and below, the present state is 0 1. That means the 0 1 is nothing but no change in interference or no latched together in intermediate stage. We can see the reset stage of 0 1 are latched with the next stage, and we can assume like this 1 0 is the latch between the set stage. Master slave SR flip flop. We have two inputs and S and R. We have two outputs, that is Q and Q dash or Q bar. Master slave SR flip flop. My master slave SR flip flop as a nothing but set reset flip flop is a type of sequential logic circuit that consists of two separate SR flip flops connected in series, referred to as the master slave stages. The master stage consists of SR flip flop with its inputs connected to the external set S and reset, that is inputs and its output serving as the input to the slave stages. Pulse triggered SR flip flop on the graphical or symbolical representation of there are 4 NAND gates and 4 NAND gates to connected in master and slave flip flop, and between the master and slave between the clock is connected to diode in slave flip flop. You can see the time diagram or time graph, that is clock is whenever the 0 that is ground and whenever the high that is 1. During the active clock edge, the master stage captures the input data present in the S and R input. The master slave edge operates only when the clock signal is high or low, depend on the specific implementation. During ensure that the input data is sampled synchronously. This arrangement ensures that the output remains unaffected by glitches or race condition, providing reliable operation in sequential logic circuits. Let's see the truth table on SR flip flop. Whenever the inputs are both of 0, then outputs are 0 and the stage is next stage, that is 1. Whenever the 0 0 in this condition, the output inputs only 1 1 and the condition is 0 0 only. Whenever the inputs is 0 1, that outputs are 0 0. Stimulation and testing. In stimulation and testing, flip-flops is an essential part of digital circuits designed to ensure their proper functionality of performance. Software tools, that is design, created the schematic or write the HDL code for the flip-flop circuit. Stimulation setup. Define input signal, clock signal, and any initial conditions. Analysis. Analyze the stimulation result including waveform, timing, diagrams, and output states to very proper functional. And finally, run stimulation. Execute the stimulation up to observe the behavior of the flip-flop under different upper or input conditions. In finally, applications, counters and timers, and frequency divider and shift register, storage registers, state machines, and digital logic circuits, embedded system design, digital signal processing, and clock domain synchronization. In conclusion, the design and implementation of master slave JK and SO flip flop play a crucial role in digital security, offering enhanced stability, reliability, and versatility through the master slave configuration. Those flip flops might get glitchless race condition and timing issues, ensuring depends on operation in sequential logic circuits. Thank you.